Question 19. A factory produces bags of flour. The weights of the bags are normally distributed with a mean of 900 grams and a standard deviation of 50 grams. What is the best approximation for the percentage of bags that weigh more than 1000 grams? First, we need to convert the raw score of 1000 grams into a z-score before referencing the standard normal distribution from the reference sheet and applying the empirical rule. Using the z-score formula, we have z equals x minus mu over sigma, where mu represents the mean and sigma represents the standard deviation. So in this case, x is equal to 1000, mu is equal to 900, and sigma is equal to 50. So substituting these values into the formula, we get z is equal to 1000 minus 900 over 50, which gives us a z-score of 2. So we want the percentage of scores that lie above z equals 2 on the standard normal distribution. Referring to the standard normal distribution from the reference sheet and applying the empirical rule, we can see that approximately 68% of scores have z-scores between -1 and 1, approximately 95% of scores have z-scores between -2 and 2, and approximately 99.7% of scores have z-scores between -3 and 3. This means we can apply the empirical rule to find the percentage of scores between any two z-scores on the standard normal distribution. And I've shown them here in red. So for example, between a z-score of -1 and 0, there's approximately 34% of scores. Between a z-score of 0 and 1, there's approximately 34% of scores. Between a z-score of 1 and 2, there's approximately 13.5% of scores. Between z-scores of 2 and 3, there's approximately 2.35% of scores, and so on. We're interested in the percentage of scores that have a z-score greater than 2. And we can get that by adding 2.35% and 0.15%, and we get 2.5%. Therefore, the answer is option B.